So in terms of lesson 2, we're going to determine characteristics of sine and cosine. Well, not every sine function is going to be the same, right? Just like what we've seen before, we've done a lot of transformation on our other functions. So we're pretty much going to be doing the same thing in here, some transformation on this other function. So the very first transformation that we're going to do is the amplitude. Okay. Now, let's see if we can read this one first. So the general form of a sinusoidal function is y equals a sine b times x minus c plus d. Does that remind you of anything? Transformation. Isn't it the transformation that we've done before? Okay, what does a transformation look like before? When we did the transformation before, we did this, right? Y equals to a f. F is a generic function, could be any function, times b times x minus h, horizontal shift, brackets, plus k, vertical shift. Oh, isn't that kind of amazing? Now, they changed some stuff in here. H is a horizontal shift, k is a vertical shift. So when we look at the sine function, it's a. Now, f is not just some generic function anymore. It's actually a specific function, and it's a sine function, sinusoidal function. So if you change that f, which is a general function, to sine, specific function, sine function, it looks like this. And then the h is changed to just c, right? So that you can see A, B, C, and then the D. Do you see the connection between the two? Now looking at this, what does the A do to our graph? Compression or stretch. So that means the graph could be stretched, okay? Could be like this, right? This is what the sine function looks like. Somewhat like that. I think it's just rough sketching it. But if I stretch it by a factor of 2, what would that look like? We could stretch it. Okay, it's nice to always connect to something that we already know, so that, you know, like this is nothing new to us. This thing is not new to us. The sine function might be new, certainly. We've never seen that one before. But in terms of transforming the sinusoidal function, so A is a vertical stretch or compression, or what if A is negative? What happens?
It's a reflection.
It's a reflection over the x. So if this is your normal function, sine function, and if A is negative, it would be reflected down. Then it would look like that, right? That's something that we already learned. We already know that. Okay, so that's what A does. When we did the function, general function, What does the B, how does the B affect our graph?
A horizontal stretch or compression.
Yeah. So the B talks about horizontal compression or stretching. So in this particular case, okay, we're going to talk about that very specifically, very, very specifically, but I just want to point out some stuff and connect what we already know. So generally, we did this previously in our chapters, few chapters ago. F B x minus H plus K. So the B is your horizontal compression or stretching. So if our graph is from 0 to 2 pi, okay, you're going to be really, really good at this one. Can I compress it? I can compress it. If I compress this graph, what would that look like? It's going to get skinnier, so it's going to go like this. We've compressed it. And then it actually fit another graph. We've compressed it. Right? That's what compression is. Can we stretch it? Yeah. So it's from here, 0 to 2 pi. This is what the graph looks like. Oh, that's ugly. Try it again. Can I stretch that? I could. So I can go like this. Right? So I've stretched it. So the period, the whole complete cycle is now 4 pi. It's not 2 pi anymore, it's 4 pi. Okay, what's this one?
Translation from left to right.
Yeah, translation, horizontal translation. So I can take my graph, this is my graph, right? I can move it this way. That's okay. And what does a K mean?
Up or down.
Up or down. So it used to be like this. Now it could be like down here. You see, like we know these things already. The only thing that we're going to do specifically is using the sine function. So, what does that mean? So the A talks about the vertical stretching and compression. B, I'll do that in here. So A, vertical stretch or compression, and reflection. Yes? The B is the horizontal stretch or compression or reflection, but we normally don't do reflection in here. Okay? And then C is a horizontal shift, right? Left or right. And then the D is a vertical shift, up or down. So do you, We know half of these already. Okay.
Is B still going to be like the factor of?
Yes, it is. Yeah. You know how like the B is this? Yeah, that's a good one. We'll get to this one here. You know, before the B is equals to 1 over the factor, right? If it says it's stretching by a factor of 2, right? Stretch by a factor of 2, it's really B is 1/2, right? Yeah. So yeah, it's going to be like that, but slightly different. That's okay. So here we go. So amplitude of a sinusoidal function, so A is a sinusoidal in a sinusoidal equation controls the vertical stretch. Yeah, we know that. Vertical stretch. If A value is anything other than 1, the A will appear as a coefficient of the sine or cos. If the value of A is negative, the graph is also reflected over the x-axis or in the x-axis. We know that. Now this is another question that someone asked. Absolute value of A. What does absolute value of A? We're only gonna take the positive value of that, right? And somebody asked already, is that positive or negative? It's gonna be a positive. Amplitude is a positive. Represents the amplitude of a sinusoidal function. If A is less than 0, the function is also reflected in the x-axis. Amplitude can be determined from inspecting the graph or by using the formula. So, amplitude, here's a formula for amplitude. Formula. And this is probably another things to memorize. Right? Maximum minus minimum divided by 2. Okay? Absolute value. Right? Because your maximum and minimum, yeah, but we want that one.
Oh, okay. Because the amplitude's going to change. I was thinking.
Yeah, our amplitude is going to change pretty soon.
Okay.
Okay, it's not going to be always 1. Okay, so study the graphs of this. Okay, there are 2 graphs in these things. This one is supposed to be, study the graphs of 3 sine of x. I think this is supposed to be, there's supposed to be a 3 here. Okay, so let's put a 3 there, positive 3. And then the second one in here is negative 2 sine of x. Negative 2 sine of x. This one right here. And the amplitude is 2, right? But it's kind of reflected down because of the x, because of the negative 1, negative 2. Sorry, just negative 2. And then here, y equals to 0.5 sine of x. That means, what's that one? Is that that's a vertical compression. So here, there's going to be a vertical stretch by a factor of 3. Right? So whatever a normal function looks like, sine function, it's vertically stretched by a factor of 3. This one right here, there's going to be a vertical stretch by factor 2 and a reflection over x-axis. Last but not the least, y equals 0.5 sine of x. What do you think happened there? Compression, right. So this is a vertical compression by a factor of 0.5. So let's see here. So what's the amplitude for the first one? 3. 3 is the amplitude. This is the amplitude. The 3. The A is your amplitude. What's the domain? 0 to 3 pi. We can go 0 to 3 pi. What's the range? So -3 to +3. -3 to +3. Is everybody okay? This one, what's the amplitude? 2. Very, very nice. Were you kind of thinking about -2?
For a second, but I remember that amp.
Yeah. Yeah, for a second you're probably thinking, this is a tricky one because the question sometimes says, what's the amplitude? But some people might say, hey, it's -2, but amplitude is the absolute value. Right? So it's going to be just a +2. What's the domain? 0 to 3 pi, so it's still 0 to 3 pi. I guess we could continue on. What's the range? -2 to +2. And last but not the least, what's the amplitude here? 0.5. And that would be 0 to 3 pi. And from -0.5 to +0.5. Start off with something easy. We're going to do this piece by piece, right? Any questions here? You good? Okay.
So the A value is
A value is going to be always the amplitude, right? So A, I'm just going to put down over here absolute value of -2. Okay. So absolute value of -2 is just 2. Amplitude, always positive. Always positive. The negative just tells us that it's reflected down. Okay. Period. Okay. So a function that repeats its values in a regular interval over its domain is periodic function. So the graph of y equals the sine of x and y equals the cos of x are both periodic functions. The period is the horizontal length of one interval or a cycle on a periodic graph. From the general equation, the sinusoidal function a sine b of x minus c plus d, the parameters b represents the frequency of the cycle within the interval of 2 pi. Therefore, the b affects the period of the formula, period of the graph. The period can be determined by inspecting the graph or by using the formula. Okay. So, period is equals to 2 pi over b. So the period is equals to 2 pi over b, if you're talking about in radians, or 360 over b if we're talking about the angle in degrees. Now, if this is this that one, we can also, later on, we're going to do this. B is equals to 2 pi divided by the period. Later on, this is going to be helpful for us, but not right now, okay? So let's take a look at this.
Period we write as P, not T?
Oh, no, it's not. Yeah.
Oh.
Yeah. Oh, physics. You notice that? Period is equals to 1 over the frequency. Yeah. Okay. So, study the graph. Y equals sine of 4 of x and sine of pi, half times x. Then complete the table below. So, here. So sine of 4x. Okay. What is the amplitude?
1.
The amplitude is still 1, right there, 1. What's the domain? Well, we could go from 0 to, oh, this is going to keep going. Is it okay if we go infinity? Is that okay? Yeah, because there's an arrow. Technically, we should be infinity. What's the range of y equals to the sine of 4x?
-1 to 1.
The range is from -1 to +1. Is everybody okay? Yeah? So 1 to 1. What's the period?
Pi.
Period is 2 pi over b. What's the b? B is 4. So the period is, so the b here is 4, so period is 2 pi over 4, which is pi half. So that means to complete one cycle, we're going to do pi half. Where's pi half? If this is pi, and then this is pi half, is that one complete period, one complete cycle? Yeah. This is one complete cycle, right? So the period is pi half. Okay, look at this one here. So B is 4. How many waves can fit into pi? How many complete waves fit into pi? I'm here covering from here to pi.
4.
1, 2, 3, 4. Yeah. So this dashed, this is the little dash, and then this is the solid. Okay. So this means you're going to have four waves in a span of 2 pi. So that means one wave, one cycle is pi half. So this is one cycle right there. That's 1. That's pi half. Now what about this one? Amplitude is
1.
still 1. Domain is 0 to infinity. Okay, we'll go infinity this time. Range is still -1 to 1. But what's the period? Period, one whole cycle is 4 pi. Or we can say P is equals to 2 pi over B, which is 0.5. 2 divided by 0.5 is 4. 4 pi. So it will take 4 pi to make one wave. To make one wave, you need up to 4 pi. So now let's see if we can use the terminology here. This is your B. B. This is your B. How can we describe this in words? Is this a horizontal compression? By 1/4. What would this be? The B is a horizontal stretch by a factor 2. So instead of 2 pi, now it's going to be 4 pi, which is 2 times more. Okay. Okay. I think I'm gonna stop right there. So tomorrow what we're gonna do is we're gonna talk about page 10, because there's a lot of things to take in here. And then we're also gonna finish up with the sinusoidal function, horizontal shift and vertical shift for tomorrow. And yeah, that's a nice way to kind of end our week. Just finish up with this piece.
This looks pretty thin.
It's quite thin, so wow, that's how many lessons are in here. We did lesson 1 and 2 today. Ah, you're gonna say, oh man, when is our test? When is our Monday? No, we're good, but I can't teach that fast. Okay, so yeah, we'll stop right here. Tomorrow we'll finish up. If you want to read ahead, go ahead, read ahead, and then if you want to see your test, if you're interested in your test, did I bring? Oh, I didn't even bring it. I can show it to you tomorrow, but either today or maybe tomorrow. If you're interested today, I'll show it to you. Okay.